With this tutorial, we'd like to exercise on Kiwi3D. Kiwi3D is a plugin for Grasshopper developed by the Technical University of Munich. And it can be used for structure analysis. So first you have to go to Food for Rhino to download Kiwi3D, the newest version. Right now it is 0.50, and when you download the file, you have to unblock it before you unzip it, and after you unzip it, you get a set of file and find the file that you need to initialize, which is an executable file. So you run the program and install Kiwi3D on your computer. Then after you have successfully installed it, and you can open Rhino and Grasshopper, and in the Grasshopper you will be able to find these tools, components for Kiwi3D. So it should be like this. And this file, tutorial Kiwi3D1, is a kind of introduction to the Kiwi3D. So here with this, I would like to introduce the major steps to create a structure system. And then we can use Kiwi3D to analyze and visualize the structure behavior of the system. So the first example will be creating a very simple frame. So we have two columns supported on the ground, and with two joints. Here I set it as a hinge joint, and then we have a beam. The span is 10 meters wide, and the height is 3 meters. So to define such a structure system, first we need to initialize the geometry. And the geometry simply need to represent this element with the basic geometric form. For example, for linear elements such as column and beams, you draw lines, and they have to separate it as isolated lines. So here I reference these lines into this one. This is the beam, and the two here are columns. So this is the basic geometry of the entire structure system. And then we can proceed to define this geometric shape as structure elements. So first, we group all the three lines. If you want to use the same or similar setup for this element, then you can group them all together. Here I use NY to put them into a tree, and then we need this beam element component from Kiwi3D. So you go to Kiwi3D. Let me show you where is it. So Kiwi3D, and there is a category called elements, and choose the one named beam elements. So it is here. And with this beam element, you need to specify a set of things. Later, we will have a step-by-step tutorial for you. And we need to define material, the sections, and refinement. I will go to detail later. So after you have specified the structure element, then we need to specify the support of this system and also the load of the entire system. And then we put all of them together to define the model. And we need to use a method or an algorithm for doing analysis It can be either linear or non-linear or form finding. You can find that from the Kiwi component. After you have defined the model, then we are ready to resolve it. So there is an IGA solver with a button to activate it. And after we have analyzed the model, we are ready to do visualization. So when you create a model, you'll be able to see the entire setup. So here it shows the support. And you can see the degree of freedom of this support from this icon. And column and beam, they are all called beam element and the joint. If the joint is hinge, then there's an icon such as this to show the type of joint. And for visualization, first we can visualize the deformation. The deformation of it. In this case, the deformation is enlarged 50 times. And we can show graphically the result for the analysis. So this is the overall introduction. Now we can go on to do a step-by-step instruction. So first, you draw. Okay, let me remove all of them. Okay, we can draw our structure system. One column, two column. Maybe this time we make a tilted. Okay, no, this one is not necessary. So, and then a beam. Now we need to reference this element to the beam. Set multiple curves, the columns. Now we can start by defining structure elements. So we go to Kiwi3D. And here, this large group are all for defining elements. We find beam element. We merge all these lines into one data structure. You can use merge or N1. Now you always look at this warning message, and you can see that you need to specify some more input. And the first one, of course, is for the curves. It is necessary. And then we need to specify parameter M here, which is for material. So we go to Kiwi3D. You can find component for material also in the element. So there are two. One is more generic. You can define the specific type of material by specifying some parameters. But here you can get some default type of material. So first we connect to it. And here for input, you need to choose which material you like. And in Kiwi3D, it's a very convenient. If you have a value list, you go to parameter, input, value list. and then you connect to the input, you will get the available section options for the type that you want to choose. So let's choose steel. And let's see, there are still 2 wanted input remaining. So now we need to specify S means section. So we go to Kiwi3D, element, and here there are some predefined sections: box section, pipe section, and or you can draw your own section and define it as the profile. So we choose the box section, connect to it. And for box section, there are 3 parameters: height, width, and thickness. Okay, the default value for height 0.2. It depends on the working unit of your drawing. And I think in this case, we have our working unit in meters. Okay, so the size of this beam, the height of it is 0.2 meter, and the width is 0.1 meter. And thickness, I think when it is 0, it means it is solid. Okay, but if you have a thickness, then and it is steel, then it is the thickness for the box. Okay, and here we still need to specify the R parameter. So when you look at it, it is called curve refinement. So again, you go to element to find it. Curve refinement. Okay, we use the default value. P degree, it means polynomial degree. It means the smoothness of the curve required for analysis. Okay, if the degree is higher, then mathematically the curve is more smooth. And U, it means the refinement or the division when Kiwi3D is doing the structure analysis. You know, computer always doing things as a discrete world, not continuously. So before it does the analysis, it has to divide the entire element into segments. So this U value will decide the size of these segments. When you have a larger U value, then the result will be more accurate with higher resolution. And but then it takes more time. So when you have a very complicated system, I would suggest that you always start with small value for this refinement. And then after you are sure that everything is fine, then you can go on to make larger U number to make more refined analysis. So after we have specified the first 4 input, it is ready to define our specification as beam elements. Okay, so there are 3 beam elements. And for the rest of them, they have default value, or either you can simply skip it. Okay, so now we want to continue on to make the whole system. Now we have defined the element. Now we need to define the support. Okay, so these are the 2 columns, and when I drew it, I always drew it from bottom to top. So if I can get the starting point This is the curve. So the support will be in the starting point. So go to Kiwi3D, and for loads here, oh no, sorry, support. We have a support point. We can define support curve. If you have like a load-bearing wall, then you have support curves. Or for the entire slab and you want to support the slab along some edges, then you use this support edge. But for column, we usually use support point. So we connect the starting point to this, and it will be fine if you specify the position and you use all default value. dx, dy, dz means displacement. So if you do not allow displacement, then you set it true in the x-axis. So the support will not allow displacement on the x direction, on y direction, and on z direction. I think by default they are all true. And for rotation, the default value is false. So it is by default is a rotatable supporting point, and T means torsion. So it is also allowed twisting, which means the support will not resist twisting. This is for more advanced. We skip it. Now we have done the load. Okay, then we support. Now we need to define the loads. So we start with a point load. We need to specify the position. So we go to curve analysis, point on curve. So we can specify the t value, and we use this beam curve. So we get the location by sliding this slider and send it to point. Okay. Load type. There are several load type. So if you have a value list, then we can see what kind of load type we have. Dead, snow, pre-stress. This one I don't know what's that at the moment. Okay, and this is the direction. By default, it is the negative z axis. The value, okay, we can have like 20. Okay, this is for dynamic loads, but we don't do it right now. So after we have got these three, we are ready to define, to put them together in a model. So we go to model, analysis model, we link E to E, S to S, and L to L. Okay, and for this one we need to choose the way we would like to do the analysis. There are linear, nonlinear, and for finding we choose linear. We can name it, just use the default name, and here we have options, so we get a value list. Okay, I think this is multiple choices. There are checkboxes, so we can have like want to do all the three types of analysis, and we connect the analysis. Okay, and Kiwi3D requires that you have to save your file before you can go on to do the analysis. Now we go to Kiwi3D, model, IGA solver.